1985. The first Back to the Future movie comes out. In the last scene, as Marty, Jennifer, and Doc board the DeLorean, about to go back to the future, Doc declares, "Roads? Where we're going, there are no roads." Well, where I'm going, there are no drivers. We're talking about autonomous cars. My name is Yael, and I'm representing the innovation team in Amdocs. We're a $3.5 billion company with over 250 communication service providers, customers, most of them being tier ones. And today I'm going to take you to the future. We're at 2020. There are billions of connected devices. And I'm going to tell you a story about Auto Motors Company, a large vehicle manufacturer company manufacturing autonomous vehicles. And Next Communication are a large global presence communication service provider. And Next have contacted, Auto Motors have contacted Next. They've asked them for secured connectivity for their cars. They want their cars to get high performance with low latency. And this is, remember, we're talking about autonomous vehicles. It's very important that the network has very, very low latency, and they want complete control over their network. So they don't. Okay. Obviously, Next can support them on everything they requested. They signed the deal right away. And let's go a few months later. No, before that, I'm sorry. How can they provide that? Next Communications have moved away from proprietary hardware for network function entities, and now they have virtualized all their network functions. So we have standard hardware. On top of that, we have standard operating systems and the application plane. So virtually a GGSN today, or in the future, will run on a virtual machine. You want it to scale up, you just pop up more virtual machines. You want it to scale down, you shut down those virtual machines. And I'm going to take you to John. He's our sales engineer for Next Communications. He's just entered the Auto Motors offices, and he's going to set up their whatever they have requested to support their connected cars. So remember, we wanted the cars to have a secure connection with very high performance, and they want complete control over their network. So as you can see, John has many enterprise customers. Now he's looking at his Auto Motors contract, and he's about to deal with the Detroit VPN contract, which is now being expanded into the autonomous vehicles connections. So what we're about to do is bring Auto Motors private network SIMs as part of their connected car initiative. Let's continue. We need to select a template of whatever service we're going to provide them. So in this case, we're going to provide them with a basic private network, which means we're going to support them with a complete evolved packet core, 4G EPC, in order to support whatever it is they need. we're talking about a trial period, so let's say 2,000 cars with a gold SLA, and let's have a quick look over here at the architecture. So what you're seeing here is the complete evolved packet core virtualized for Auto Motors, which means that they're going to have their own network. It's going to be completely secured, because right now you see that their core network is connected to the internet, but me, as John, the sales engineer, is going to be able to connect the network over directly to the Detroit VPN, which means it's going to be extremely secured, not going through any internet base. That's about security. Now let's talk about the high performance. Since this is all a virtualized environment, all of these network entities will be sitting in the cloud, and we can deploy them wherever we think is right and fit for this purpose. In this case, since it's all connected to the Detroit VPN, we'll deploy them all in the Detroit data center, which means they'll have very low latency and very high performance. Remember, this is autonomous vehicles that we're talking about. And lastly, we talked about them being able to control their network. So they have their own PCRF. They can configure their own policies. For example, if Auto Motors were to have high-end cars, they could give them very, very high quality of service, whereas their low-end cars could get a lower quality of service. And this is their all of this is in their entire control. They don't need to compete with anyone else on the network on this. So we've had a secure network, high performance, great control, all of this over virtualized systems. And since, as you saw how simple it is for John to describe, whenever he'll press submit, this will go directly to the network administrator, automatically be deployed in the network without anyone having to touch or do anything about it, which means they're going to have significantly fast time to market for this. So as we said, secure, high performance, complete control, practically zero time to market, and this is just a bit of a glimpse into the future of what Amdocs is going to be doing with NFV, Network Function Virtualization. Thank you.